Live. Okay, so one of the things we know about circles, it's the perfect shape. What makes it the perfect shape is the fact that it's a circle. So all sorts of interesting things happen because it's a circle, okay? But today we want to talk about the line segments in the circle. The line segments, not the angles, not the arcs, but the actual line segments, the lengths of them, okay? So today we're talking about chords and secants in circles, okay? 5, 28, 19, okay? So those are the line segments. The line segments. Chords and secants, okay? And even tangents. So here we go. So I drew mine a little bit different, but it's called the secant segments of a chord theorem. And I did mine differently. A is this length. B is this length. How long is it? Maybe it's 3 inches, maybe it's 5 inches. Who knows? But it's the lengths, okay? So if you have two chords that intersect in a circle, then you have a cool little relationship where this piece times this piece will equal this piece times this piece. Or A times B will equal C times D, okay? So this piece times this piece will equal this piece times this piece, always. It's a cool little relationship, only happens in circles, okay? And we'll look at some examples on the back, all right? Now, in example 2, what happens on 2, and you got to watch, everybody watch. There is the piece on the outside and the entire piece. The entire piece is A plus B. There's the piece on the outside and the entire piece. The entire piece is A plus B. There's a piece on the outside and the entire piece. The entire piece is C plus D. So this ratio goes A, the piece on the outside, times the entire piece. A plus B is equal to the piece on the outside, which is C, times the entire piece, which is the C plus D. Yeah, you can do that. Yes. Yeah, you can do that. Hopefully we can add these first. But yeah, you're totally right, Derek. Okay? So it's the piece on the outside times the entire piece equals the piece on the outside times the entire piece, okay? So A times A plus B equals C times C plus D, okay? Number 3 is the exact same formula except for the fact that C is by itself. Does that make sense? So you got the piece on the outside times the entire piece, which is A times the entire piece, which is A plus B, equals the piece on the outside, which is C, times the entire piece, which is C. So it equals just C times C, or C squared. So it's the exact same formula. The piece on the outside times the entire piece. The piece on the outside times the entire piece, okay? So these are pretty easy formulas, and they work with segments in circles, okay? So if we flip the page, let's take a look at some examples, but I'll wait for you, okay? I'll wait for you. Okay, thumbs up. Okay, let's look on the back. Okay, so example 1. What we're going to do is this. You ready? This times this equals this times this. Or 10 times 6 equals x times 12. Or 12 times x. 10 times 6 equals x times 12. 10 times 6 equals 12 times x. Okay? That times that equals that times that. See, it's that easy. So I get 60 equals 12x, right? Divide by 12. Divide by 12, x is equal to 5. Thumbs up? Thumbs up? Pretty easy, isn't it? Right? It's pretty darn easy, okay? B might take a little bit more work. We might even have to factor. So what? Still the same thing. We're going to go this times this equals this times this. This piece times this piece equals this piece times this piece. So we're going to have a x times an x plus 8 equals a 6 times an 8. Okay? X times x plus 8 equals 6 times 8. Okay? This piece times this piece equals this piece times this piece. That's it. Now we might have to do some factoring. We can handle that. I'm going to get a x squared plus 8x equals 48. Good, right? Not yet. Let's bring this over and factor, okay? So I've got x squared plus 8x minus 48 equals 0. Let's see, 48. 12 and 4? 12 and 4, right? 12 and 4. Why am I saying 12 and 4?
Because
If I factor it, right? If I factor it, if I go x and x, right? We're going to have to factor. Remember factoring? Oh, yeah, we're going to have to factor, okay? So then I've got, let's see, plus 12 and a minus 4, right, equals 0, right?
Yep.
If I get my mini equations, hi Landon, I got an x plus 12 equals 0 and an x minus 4 equals 0, right? Minus 12, one answer is negative 12. Nope, can't be. Hold on just a second, I'll tell you why, and x equals 4, okay? Cannot be negative 12, can't be, because we're talking about lengths, right? We're talking about lengths, and you can't have a negative length. You guys agree? Negative length doesn't make any sense. Negative 12 inches doesn't make any sense, right? So you throw that one out. So then, x equals 4, okay? So if x is 4, let's go back to the picture, okay? So if x is 4, then this side is 4, and this is 4 plus 8, which turns out to be 12. So I do get the 12 after all, don't I?
Mm-hmm.
Yeah.
but a positive.
Yes, it's a positive. Totally right. Okay, so far so good?
Yeah.
Okay, let's look at C. So C is the piece on the outside times the entire piece equals the piece on the outside times the piece. Yes. So I'm going to write this. I'm going to go 6 times 6 plus 10, okay, equals 8 times 8 plus x, okay?
Doesn't make sense.
It's the piece on the outside times the entire piece, right?
So
Piece on the outside times the entire piece, okay? How am I doing?
4.
Yeah, you're ahead of me. 6 times 16. You could distribute, but why not just go 6 plus 10? You could go that times that times that, but why not just go 6 plus 10 equals 64 plus 8x. How am I doing?
74.
You're way ahead of me. I like that. Okay. Is it 74? I believe it's 6 times 16. 96. 96 equals 64 plus 8x. That's why I checked. Didn't sound right. Minus 64, right? And so I get 96 minus 64, and I get 32 equals 8x. Yeah, divide by 8, yeah. X equals 4. Okay, not too hard, you guys agree? It's not that hard, right? All right, last but not least, we'll do D. Am I going too fast? Okay. Am I going too fast? I'll wait for you, Aiden. Yeah, I'll wait for you. Okay, I'll put this phone away while I'm waiting for you. Right? Okay, last but not least, thumbs up. So, it's the piece on the outside times the entire piece equals a piece on the outside times the entire piece. So we're going to go x times x plus 12 equals, okay, piece on the outside times the entire piece equals the piece on the outside times the entire piece.
Could we just put a square for that? X plus 4 squared.
Yes. But then I'd probably rewrite it like this because I got to do the FOIL. But
Okay.
totally correct. Cameron, totally correct. Yep. Okay, I got to solve for x. So here I go. Okay, ready? Am I going too fast? I'm doing okay.
You're good.
So x squared plus 12x equals, right?
Squared plus.
X squared plus 4x plus another 4x plus 16. Okay, how am I doing?
Pretty good.
So what? Just 8x.
Yes. X squared plus 12x equals x squared plus 8x plus 16, right?
X squared's cancel.
X squareds cancel. Nice job, Cameron. I totally agree. You guys agree with Cameron? X squareds cancel? Because you can subtract x squared from x squared. So now it's getting pretty easy. 12x equals 8x plus 16, right? Minus 8x 4x equals 16, right? Divide by 4, x is 4. Which then I can go back up to the figure and figure out what everything is, right? So if x is 4, then this is 4, and this is 4 plus 4, and this piece is 8. How's that? What do you think? Can you do it? It's really pretty easy, okay? All right, so we have lots of time to get homework done. I'll pass out homework in a sec.